to this computer. Okay, so that's the whole idea. As we said earlier, we are going to again discuss chapter 15. And chapter 15 again is about functional programming language. And the reason why, again, as I said, I can say that we are going to be behind a little bit because we have only 2 weeks left, and Thanksgiving. After Thanksgiving, we have like only a week or 2 weeks, and we need to take at least 2 or 3 tests. So what will happen by the test is that we're supposed to say 6 tests. By the way I'm looking at it, I don't think we will take 3 tests more because the time is not there. But I'll make it very straightforward. If we take let's say we take 4 tests, all the 6 tests supposed to be 300 points. So if we take 4 tests, then I'll still make it even for the 300 points. Hopefully everybody understand what I'm saying. So if the test is 50 points and we take only 3, then one test will be 100 points. So I'll update it so that I'll keep the 1,000 maximum points still for the final grade. So that's our first objective again. And we'll go through the introduction concept. Then we are going to talk about mathematical functions. The mathematical functions, hopefully, we may not go detail here. For example, we all know the concept of functions. So functional programming language, the whole idea is functions. Even your argument can be functions, etc. And the value can be functions. So here we talk about mathematical function. Let's say if we have something like this equal to x squared plus, let's say 10. Yeah, this is a function. This means I will say y. So we know if I'm using y, then I'll say y will be what? The output variable or the dependent variable. Then x will be what? The input variable or the independent variable. So x will determine the value of y. Whatever x is, we may get different value of y. So this is the whole concept of functional mathematical functions, which means we can also say y is the range and x will be the domain. So here we can map the domain to or I would say map y to x. We may have some function to do that. So the good news with functional programming is that there's no any, so here will be actual value. There's no any variable here. X is not a variable, it's actual value, same as college algebra, etc. We may also have something like a composite function, where we may have one function inside another function. Let's say I may have g at x, f at x, and I can say this is s plus 2, s plus 3, and we can get a new function. We can say that g at x, something like this. So this is a composite function, which means the argument of the function is also a function. So this, I can write this as what? First of all, I have to write the f at x first. So f at x is what? S plus 2. And anywhere I see x, I'm going to substitute what? G at x. G at x, because the argument is g at x. So s plus 3. So this means the solution will be s plus 3 plus 2, which will give us s plus 5. So that is the concept of composite function. Sometimes we can write it in a form like college algebra. I think we write g at x. Something like this. If I write it this, it means g at x is the argument of this. Or if I write it the other way, like this, it means I'm going to write this as g f at x. So now f at x is the argument of g. Then we do the same concept to solve the function. So that's the whole concept here. And also we're going to talk about the lambda operations. Actually, that one is straight in the slide, so that one. This is not in the slide, so just to explain what is the concept of functions. So college algebra functions, that's it. Okay, so that will be 15.2, section 15.2. Then also we are going to talk about the fundamental of functional programming language. I think that's where we're more into. We will start with the Lisp, how Lisp work, then we talk about scheme. So we start with the theory. So here we say, in theory of computing, a program is viewed as what? A function. And a program map such input to some output. But again, if we talk about imperative language, sometimes there may be some side effect or some other state. The variables can be in different states. We can overwrite it, etc. But functional programming, it's not like that. So here, for example, we say input. We give us the output. We map the input with the output. Also, in this case, functional programming language will be deterministic. Deterministic means if I know what is the value of X, we can know what is the value of Y. So deterministic program. Now, as we said, imperative, maybe we may have some Stack Overflow, variable, undesirable element, or stack. Again, as we said, why we have this in functional programming language? Simple, because the value of X, or I'll use this one, the argument X is a value, it's not a variable. So in functional programming. And we will see the theory, they will repeat it to us a lot in the textbook. So this is how we're going to write it. Output equal to P at input. So P will be whatever the function is. So here we'll say the program. So if I have a program, we have an input. The input also can be a function, or I'll say the argument can be another function to generate an output for us. So the functional programming language is 100% deterministic. So here we say a functional program puts this model into practice. Programs are written in terms of what? A sequence of functions, same as college algebra concept. So so here, for example, we have a composite function. P at input equal to what? We have a function, then we have another function G, then we have another. So this is nested function. So if you are doing execution of this, H at X, let's say the input is H at X will execute first, then it will give the result to G function. Then G will execute, then it will give the result to what? F, then F also will execute. So they say the evaluation or evaluating the program produce the output for us, which is on our left side, a composite function in this case. So what are the characteristics of a functional language? It doesn't matter whether it's a ML or it's a Haskell, F#, they all have something in common. But I would say that the pure programming language, I would say Scheme or Lisp. Because, for example, in ML, we can use assignment operator in some limit. And also in ML, operation is, I think we discussed this before. Let's see if it's okay. Operation in Scheme and Lisp is what we call the prefix. So I can write always the operator will come first before operands. Operator plus, minus, multiplication, division, at least need 2 values. If it's plus, it's okay. But now, this is the good news. In Scheme Lisp, we don't have plus. Because it's increment. Plus because it's a variable, we increment the content of it. If we want to increment, we have to write it ourselves. So also I cannot write S equal to S plus 1 in any of the functional program. This means I'm increasing the value of S, then I put it in there's nothing like the same place. It have to be different. Let's say this will be Y equal to S plus 1, that's fine. So in Scheme and Lisp, we use the prefix, this example. But with ML, it's good. We use the same thing. And also Haskell, again, we'll see all the differences among. The book cover F#. They also cover the Scheme. They didn't talk about the Lisp because Lisp is almost the same as Scheme. Actually, Scheme came from Lisp. Then we talk about ML also, mental language. So that's the characteristics. So the characteristics of all the functional language is the same. Here we say everything is based on functions as mappings, as in mathematics also the same concept. So we have, for example, the domain, then the range. So again, the domain will be whatever we set. So we'll see as and also here we say the functions are referentially transparent. What we mean by referentially transparent is the same concept as the deterministic program. If I know my x, always my x will give me, the function of x will always give me the same answer for y if the x is the same. So there's no any side effect or anything. So here we say the mapping does not depend on any state. If the value is 1, you use 1 on the function 100 times, you get the same result. Also, value return depends on only what the parameters. Actually, this is the main one I would say. The concept here for referential transparent means, again, whatever you have as the parameter, as the input, will give you the same output always. Because, again, it doesn't depend on the state or any other issues with the variables. So you say the function do not have side effects. I think we talked about what is a side effect already. For example, if we have a mismanagement of memory locations or undesirable effects, which can cause changes in our output or based on memory, etc. Okay, so let's see the next variables represent. So this, we said this already in functional programming. Again, variables always represent value, not memory location. So variables are values. And in pure functional language, assignment is not allowed. So that's why we cannot say x equal to x plus 1. We cannot. Assignment is not allowed. Assignment is equal. X equal to 10 or y equal to s plus 1. And this is for almost all functional programming language. Also, we said the repetition is not allowed for looping. We don't use loop, but rather we use recursion. And we shall see that. So repetition is done by recursion instead of iteration. Iteration will be loops. We don't use loops. And also we say here we cannot write for loop. We cannot write while loop. If you don't have no variable, you need a variable to write because you have to increment the program counter, which is a variable. So without a variable, you cannot use a loop. Also, we have automatic memory management also. That's another. So these are the qualities of I would say the quality of a functional programming language is more simple, very simple, and it has a less syntax. You can write a code, a very short line of code. So it's normally used for prototype or rapid development of something. So it's very, I would say, one of the main objects. But again, we'll go through the advantage. So the quality of functional programming languages and functional programs, all procedures and functions that distinguish incoming value, the parameters from output. So we said this already, always the output depends only on the input. The result always depends on it. And it's like we are repeating here again, there's no assignment operator. And also no loops. And also the value of a function depends on only what? Only the parameters. Let's wait for a few seconds if it's okay. And also functions are first-class data values. So as we mentioned before, functions again can be used as an argument, as a value. Then we will see some code, especially the book cover a lot of scheme. So we may see scheme code, if not today, Thursday. So these are some of the concepts we only cover the imperative language, object-oriented programming. So we are hoping that after we finish with the functional programming, we shall go through the logic. Logic programming is chapter 16. Chapter 16 is logic. So here we say it depends on the type of problem we have. For example, here we say different language have evolved to support each style of programming. So we know Von Neumann model support only imperative language because Von Neumann assuming variable, there's a variable. So here we say each type of language rests on distinct model of computation, which is different from Von Neumann. So logic programming, functional programming is totally different from, again, Von Neumann model. I think we discussed Von Neumann model previous chapters, which is 100% based on imperative language, which they said here, the design of imperative language is based directly on the Von Neumann architecture because imperative language variable is a variable. When you declare variable, it's a variable. Again, in functional, there's nothing like a variable. If you have a location of memory, you put a value there. So we deal on values. And that's what they are saying here, again, which we already, the design of functional language is based only on mathematical functions, the concept of mathematical functions. So functional programming language, these are some few things it does for us. Provide a uniform view of program as what a functions, as a functions. Also treat functions as data, as we said earlier. You can use function as argument. And also provide prevention of side effects also. And one of the useful rapid prototyping, artificial intelligence. If you look most artificial intelligence textbook earlier stages, we will see scheme language lives very common. Prolog also we can use for, because they are very straightforward and less coding, etc. Also can be used in logic concept, mathematical proof systems also. Now here we said if we ignore the how and focus on the results or what of the computation, then the program becomes what? A virtual black box. We don't care how, again. So here the whole goal of functional programming, again, actually that's what we said, the mathematical function is a mapping of members of one set called a domain set to another set called a range. So normally in college algebra, the range will be the y values and the domain will be the x set of values, etc. And that will take us to the lambda expression. So this is a very good expression we have here. If we actually, there's one example given to us. Let's look at the example. So this is a lambda expression that x times x times x, this is s cubed. So we can have a function cube at x means it's x times s times. So lambda expression specify the parameters in this case, and also the mapping of the function in the following form. And again, we will see example right now, just going through the terminologies. So the first, we have the domain. As we said, the domain will be a set of college algebra, set of s value. What is range? What is independent variable? So independent variable will be the x values, Again, right now we're going through definitions and also terminologies. Also, we should know what is a dependent variables. Also in mathematics, sometimes we have a partial function. Partial function means what? The x values we have or doesn't apply to the output. So here we say occurs when f is not defined for all the x. So the s values are not all for the function. So that's just a definition. And we have some, the major difference between imperative language. Actually, we said this already, so we're just repeating it again. The difference between functional imperative language, no loop, no variable. In functional language, if I want to write a loop, of course, there's a way to do it, which is, again, we use recursion. No side effects when you call a function in functional programming language. And also with functional programming language, you can have a function as an argument. And every variable is always a value. Every variable is a value. Wait for a few seconds if it's okay. So the same thing we are repeating here again. Variables are values. And also variables values cannot change. So that's why we cannot say s equal to s plus 1. We cannot do that. We cannot do that. Also, there's a lack of assignment. We don't use that. We can use assignment operator, but it's not like saying s equal to s plus 1. Assignment means equal, not, I'm not giving the value on the left. So, for example, as we mentioned, in scheme of lists, if I say this, it means I'm saying that s equal to 10, not saying that 10 assigned to x. It's a value. And that's two examples given here. For example, we have our first function. This is, again, using a C language. Then we have a second function on the right side. So the first one is imperative version using what? A loop. You can see the first function we are using the while loop to solve a GCD. GCD is the common denominator, greatest common denominator. And the code is right. You use the modulus operator. But you can see that it's imperative why we use a loop. But the second one also is a C language, because here you can see we have an infix. It's infix. But here it's a functional version. But because it's recursion, this is a recursive statement. This is the base case. If v equal to 0, then we return only u. It means if I'm finding the common denominator of 20 and 0, of course, the greatest common denominator will be 20. So that's the recursive statement here. Then other than that, we call them, that's the base case, sorry. Recursion, the base case. This is the recursive. Recursive statement is always where you are the else section. So here we just want to know the difference between the two. Yes, we can do, so imperative language on the right side, which is recursion, that's the only one we can do in functional programming language. But this is again C language. We just, so even in Java, the same thing. Java I can use a loop or I can use recursion. Java support both. So same thing with C, C++. But again, in functional programming language, especially Scheme, which the book go more detail, there's nothing we can't use loop at all. So we talk about what is a referential transparency already. It's more or less the concept of deterministic program. My X always will determine my Y, or my input always determine my output. There's no any side effect, etc. Then we also talk about the lambda expressions. So for example, this is a very good example. We have a lambda expression function for cube. So we have lambda at x times s times x, and we say 2. If I enter 2, it means x equal to 2. So 2 times 2 times 2, it will give me the result of 8. It will give me the result of 8. Then we have higher forms of function. For example, composite function, function inside another function, etc. And that takes us to this concept here. This is the only example. Again, this example straight from the textbook. So the symbol for composite, we have F composite G. F is given to be, where's the value of F? Oh, let's see. Okay, so, oh yeah, right here, see. G at x is 3 times x. F at s is s plus 2. So if you are looking for F composite G, F is outside, so I'll write s plus 2. Anywhere I see x, I will put 3 times x, and that's what they did here. So that's the concept of composite function. The book also explains it. Actually, this example is straight from the textbook also. So wait for few, I think we do this a lot in college algebra, how to find a function, polynomial, composite function, etc. Wait for a few seconds if it's okay. Okay, let's keep going. Okay, so the next, we also have example. We will see this in the scheme, applied to all or evaluation. So the concept is given here. We have our function is h at s equal to s times x. And we can see that they give us the argument. We have 2, 3, 4. So, oh, okay. H at s is s times s. So we have to square 2, we have to square 3, we have to square 4. Because we are calling h here. And each h at s is to square. So alpha for h, 2, 3, 4, everything here we are going to square. So we get 4, 9, 16 again. This is the concept of lambda expressions. Wait for a few seconds if it's okay. Okay, let's keep going. So here also we talk about what is a referential transparency. This is just to summarize everything. This is the last slide. So let's wait for a few seconds if there's a question here. This is what we should know about, again, functional programming language. As we said, FPL is functional programming language. It's to mimic what? Mathematical functions. And also computation is done different, etc., than imperative. And we said no variables, no loops. Referential transparency is important, which means the program is deterministic program. Always S will determine Y. Input determine. So this is all we learned today. the concept of any type of functional programming language. If no question, then let's start with the scheme. Let's see. Yeah, we have a lot of time. So we start, or let me wait for a few seconds, see if any question. If you came in late, I'm recording the lectures on Zoom. So it's Zoom right now. So later I'll put it in the classroom. It depends if it's okay. So if no question, let's move on. I'm going to stop this again.